QSim, Quantum Computer Simulator Toolkit. In order to address the common challenge of advancing quantum computer, IIC Bangalore, IIT Roorkee, and CDEC has launched QSim, and it was funded and supported by Meity, that is Ministry of Electronics and Information Technologies. The prerequisites for QSim includes the basic knowledge in Python programming, Qiskit, and density matrix formalism. Who can access the QSim? So the in order to access the researchers, faculties, and students who want to explore quantum computing, an email must be sent to qcworkbench@ctech.in order to get the access. So the features of the QSim includes the simulator is integrated with graphic user interface based workbench, allowing students, researchers to create a quantum programs. We can simulate noisy quantum logic circuits, and it has preloaded quantum algorithms in it to give a head start to the user. And as we are provided with resources, so there will be advancement in quantum computing. Research will be cost effective in this manner, and most important, overall Indianization of technology will increase. That is the dream of Atmanirbhar Bharat will be possible. So there is no installation required for this. You just need to enter qctoolkit.in in any browser and then sign in into it and get started using it. As we type qctoolkit.in in any browser, we can get this type of terminal open there. There is one button that is launch workbench. When we click on this button, this will let open to the login page, and we have to enter our login credentials over here. When we enter our login credentials over here, we can get this kind of terminal, that is the QSim or the QC workbench. Here we can begin learning with an intuitive user interface, and we can see what is happening at quantum level. We can induce, there are so many things over here. Here is noise parameters. We can induce quantum noise. We can change its value. Here it is 1, we can reduce it to 0. It will give the output without noise, and when we increase it to the 1, it will give output with noise. And there is like real quantum computer may suffer errors from many sources, but QSIM allows fine-tuning errors and help us in designing the error resilient system. It has here we can see it has preloaded algorithms in it, and such as Grover's algorithm, Dodge's algorithm, and QFT, and so on. So there is, we can simulate the high performance computing resource on Param Shavak and Param Siddhi AI and visualize the result as well. And yeah, as I was talking about, we can get the result with and without noise. So this is one example here. Here it is the example of density matrix formalism, or the density plot with noise. So this is the kind of plot with noise. We can check the code over here. There is the factor, noise factor 0.9, 0.9, 0.9, and this is the result with noise. We can see one more result without noise. So yeah, this is the kind of result without noise, and we can check code over here. So it is 0, 0, 0. All the values and all the factors, all the errors are set to 0. So this is very intuitive and help us to understand it more clearly how it works, and simulate the quantum circuit with and without noise. And there is the simulation option over here, and the quantum simulation are performed under the HPC, high performance computing resources, and it allows the multiple users to submit the job simultaneously. And user interface with graphic user interface based workbench allows us to create the quantum program and visualize the instant circuit generation over here. Here we can type and edit our code, and from here we can run our circuit. This is all about the QSIM. One more thing is the simulation option. When we enable this thing, it will show the plot in the result, and show the partition, and it will initialize the uniform superposition and 2-3 more options. So QSim is an effort in the direction to enable researchers and the students to carry out research in quantum computing in a very cost effective manner. So this is all about QSim.